Hello, everybody. Good morning, and welcome to this February webinar, this Minnesota Electric Aviation Network webinar. Today's webinar will be about the U.S. Department of Transportation's National Advanced Air Mobility Strategy. This webinar series is sponsored by MnDOT's Office of Aeronautics and is administered by the Airport Technical Assistance Program, or AirTAP, at the Center for Transportation Studies at the University of Minnesota. My name is Jackson Piper. I am a program coordinator at the Center for Transportation Studies. This webinar today is being recorded and will be available to watch at a later time on our website, airtap.umn.edu. All of the sessions are recorded and can be viewed at a later time. This webinar series will be going through June of this year. You can see our next date here is March 19th, and April 16th will be the next date after that. This is a Zoom webinar, so you can hear and see us, the panelists. We cannot hear or see you. If you have something you'd like to share with anybody in the chat, if you want to share ideas or let us, the panelists, know that you need some technical support, please do that in the chat feature there. And if you have any questions for the speakers throughout today's webinar, you can do that in the Q&A as well. So I'd like to welcome Peter Irvine, who is the Deputy Director for the Office of Aviation Analysis and the Executive Lead for Aviation Policy at the U.S. Department of Transportation, and Ryan Steinbach, who is the Aviation Policy Coordinator for the Office of Aviation Analysis. Ryan, I will turn it over to you.
Thank you so much, Jackson. And thank you, everyone, for attending. We were very happy to be talking to you. I have to apologize. Peter Irvine is an executive in charge of aviation policy at the Department of Transportation and often gets pulled in many different directions. He is working to join us and will be coming on soon. But I'm very happy to work for him as an aviation policy coordinator. One thing to get quickly out of the way is the Department of Transportation does in fact have an aviation office. There was a Civil Aviation Bureau, but back in 1978, and no, I was not working for the government at that time. It was when the airlines were allowed to have free rein over their own economics, and it was deregulated. Then what was left of the Civil Aeronautics Board was then made into an economic policy and economic fitness and a licensing office in the Department of Transportation. So while the FAA is a mode of the Department of Transportation, there is a separate aviation office in the Office of the Secretary in the Department of Transportation that focuses on the policy that is broad, economically based, and looking to enable aviation in different ways across the United States. We also do competition and things like that. But for advanced air mobility, the reason why the Department of Transportation's Office of Aviation and International Affairs was given the lead for the Advanced Air Mobility National Strategy is precisely because our job is to take aviation policy and look at it across the whole panoply of safety, economics, infrastructure development, community engagement, and how to make it work as a market. And so that was something that was given to us back when Congress put together the Advanced Air Mobility Leadership and Coordination Act. And we had a ball running with it, thinking of all the implications, what it could be, doing projections, and then getting together. In the end, it was more than 80 people, but more than 20 federal agencies, offices, special offices, parts of the White House that ultimately wanted to help. And we found it very easy to say, hey, would you like to work on a special project that's going to be a couple years and it's going to work on advanced air mobility? And then usually we would accompany that with some video of some of the early flights of then what were experimental aircraft, now nearing certification. And it was very easy to get people to be like, oh, yeah, I want to work on that. So That is why this was a Department of Transportation project, but it did very heavily involve the FAA, which we'll get into as we go forward. But I'm done letting you know the background and the reason why we're talking to you. Let's go ahead and talk about the AAM National Strategy itself. Thank you so much, Joseph. And we want to do advanced air mobility because when we look at it, not just at the DOT, but across the federal government, as we studied this for over the past 3 years, we really do see that it's going to bring innovation to all of aviation. I can tell you that one of the early meetings we had where there was some skepticism about whether electric aircraft or advanced air mobility, which is far more than just electric vertical takeoff and landing aircraft, by the way, if this was even going to be a thing, if it was going to prove viable. And one of the things that we made clear is that advanced air mobility in our own economic projection is never going to grow to the size, at least the economic market that we see for what flies today. The national and international flights that we see with Big Steel under Part 121, that is going to continue to be billion-dollar market. Now, maybe advanced air mobility will get there someday, but as it begins, we see even in mature state, when we get to routine commercial operations, it might make 7% of what we think the international and national 121s are going to continue to do in our own GDP. So this is what we would call a niche market, but it's still going to be billions of dollars in a niche market that we think will be worth it. And to me, the bigger idea is some of the innovations that are being used to make advanced air mobility work, they're going to spread into general aviation and they're going to save lives. Some of the safety enhancing features, they're going to spread into traditional aviation. We're hoping that this will spark a revival in regional aviation. Over the last decade, we've seen that regional aviation has been drying up. It's just not affordable to operate anything that with fewer than 70 seats in the United States, just because of the load factors you need in order to make a profit. And so we have a big gap between the 9-seat market and below, and for air tour operations and small operations and private operations. And then to get the public flying, you really need to be operating 70 seats or more in order to start turning a profit. And we see, for instance, our office runs the Essential Air Service, and we subsidize flights, and some in the state of Minnesota. And that expense just keeps going up and up and up because operating costs keep going higher. Profits keep diminishing, and therefore it's getting harder and harder to serve rural and even some suburban areas where you're just not making enough margin in order to support a commercial operation. We really think advanced air mobility is going to come in with lower costs, new ways of doing things, and their economic market, because they won't have the range that the 121s do. They're going to be able to, we hope, at scale, revive regional aviation and really bring business to our general aviation airports, create expansion in infrastructure development for aviation. So we saw a lot of benefit. And once we said that we think that this spreads to make aviation in general better, we were able to get a lot of people on board and win over even the skeptics to say this is going to be a project worth doing. So to the project. Next slide, please. As I was saying, when we look at advanced air mobility, we see a lot more than just getting passengers to hop from building to building in the city. In fact, we think that's going to be one of the hardest jobs or one of the hardest use cases to get going. But we do see that there could be medical implications, logistics implications, defense applications. We've become very good friends with folks over at the Department of War and at DHS for some of the ideas that they have to use advanced air mobility. We do see new capabilities, airspace modernization, which is a very big topic right now. We think that some of the technologies that are being looked at to make low altitude advanced air mobility airspace work are going to be modernizations that we should be working into later phases of our own brand new ATC system in order to make things more efficient and in order to allow people to do a capacity there. So we see simplified piloting, and we like that. We want to get more pilots in. We want to have more people able to operate more aircraft. Again, we see a revival of the regional market, and then we do see urban air mobility becoming a thing, although that's going to be a bigger challenge. Next slide, please. So again, sorry, I'm just getting a bit repetitive, but AM technology could revive regional air service. And the new propulsion systems and airspace management will also be proven with AAM aircraft. If electric's going to work, it's going to be proven in the AAM area. If hydrogen is going to work, it's likely going to happen first in the advanced air mobility area. We already see Joby doing tests with hydrogen version of their S4. So we're probably going to see it develop at the small scale. The AAM is probably going to be a great proving ground for the technologies that we want to see spread to other parts of aviation in general. Next slide, please. All right, the overall challenge, and there's supposed to be a cool video playing next to this. I apologize. We had some technical difficulties, so what you should be seeing is an AAM aircraft in flight. But the overall challenge that we do have is how do we extend beyond the current paradigm that aviation is in today, the hub and spoke model, the very human-centric pilot, very human-centric ATC, that does have human capacity limits on the number of operations that you can monitor and coordinate at one given time. How do we take that and then make microcosms of what we've achieved across the nation in different regional and urban spaces and make it handle more operations at reduced separation minima with aircraft that are flying vastly different profiles instead of all trying to come into a charted block of gates. So it's a big challenge. Integrating this is fundamentally difficult, but this is how we're going to go about doing it. We led the interagency effort. Our vision was to get a whole of government, every expert that we could find from NASA, from the Department of War, from the Department of Homeland Security, from the Council of Economic Advisors, we had people from the Department of Commerce talking about international trade with us and supply chain, securing that. We had folks, believe it or not, from the Department of Veterans Affairs. How can we improve medical things there? We had folks in the Department of Agriculture talking about, is this going to involve sustainable aviation fuel and feedstocks? And is this a way to encourage agricultural growth? We had folks I'm trying to think of some of the more obscure, Department of Energy, that's easy because grid strengthening is going to be a part of this. But our plan was essentially get everybody we could, invite everyone through the Office of Science and Technology Policy. We sent invitation letters to every agency saying, we're not going to tell you whether or not you have an interest in this. We're going to describe what we think this is, what it is we aim to do, and we want you to tell us if you have an interest, what it is, and who can help us do this. And we had an amazing response. Again, more than 80 people helped write the national strategy, more than 20 agencies. Next slide, please. So the pillars of the strategy, when we all sat down, the first thing we did, and this is back in March of 2023 now, is we said, we got to figure out what is it we're trying to solve. And so we did go into a windowless room in the Department of Transportation. For 3 days, we sat the 80 people that we had gathered, and we said, okay, let's define what we mean when we say advanced air mobility. Let's talk about every possible challenge that would keep it from success. Let's organize these into pillars or into buckets, what we call them then, of things that need to be solved and get ourselves organized in a way that's going to make this something logical and coherent. So we did that 3 days, and people actually did enjoy being in the windowless rooms where we were really talking about and talking across agencies. If you're going to allow anybody to the board on any vertiport that you build at any place, and then you think they're going to land at a terminal and get right onto an airplane, DHS would say, wait, where's the screening come in? Where's, who's vetting these people that are now suddenly landing on the air side of an airport? And so we have to then talk through and we were essentially doing 3 days of tabletops to say, do you have an interest in this? And what is your concern? How is this going to work? Ultimately, we came up with this structure of 5 buckets of looking at automation, and the engineering aspect of this, airspace, how we were going to manage and modernize in order to have greater capacity, The security aspect of it, which really did become its own pillar and has several things that need to advance as operations advance. Infrastructure development, and you'll see not just the visible infrastructure. We're not just talking about pouring concrete, but we have the energy in there. We have the spectrum in there, which is probably one of the hardest resources we had to talk about. Some of the hardest conversations we had were with our FCC colleagues, and we still call them colleagues, so that did go well. Community engagement. This doesn't work if towns reject it. For anyone that was watching the Olympics back in when they were at Paris, Volocopter was supposed to be flying athletes at Paris. It was really publicized. This is going to happen. There was a barge that was going to be in the river there, and the people of Paris were like, "No, we don't want this." And it didn't happen. So that is a striking demonstration that community engagement really does matter. And it's not just acceptance. It's actually working to get the permit, the land governance, the noise, all this figured out at the local level while still working with the federal level, because the airspace is still our problem to solve, working hand in hand at the local level. So it's engagement. It's not acceptance that we needed to do. And then workforce development, we originally had as a part of community engagement, because you're going to need highly localized workforces for AAM to work. But it became such a big thing. We ended up making it its own stream. For anyone who's read the strategy, hopefully you have, you'll see that it did end up getting its own 3 recommendations. So we made it a separate pillar. So ultimately, we ended up with 6 working groups. And then there's a 7th pillar that was the miscellaneous things that we were finding along the way and that we were capturing as a program facilitation team. Next slide. So our plan for release did happen on December 17th. The secretary did formally announce that the national strategy is out there. And it's an AAM national strategy and a comprehensive plan. If you have only read one of the documents, then you're missing, I think, one of the key pieces. The national strategy itself gives the 40 recommendations that we ultimately came up with over that 3-year period of learning and writing together. But the comprehensive plan we put together, because when we came up with the 40 recommendations and all agreed to the 40 recommendations, we said, okay, how are we going to do this? We've just built an elephant, but the government doesn't do anything as in sweeping broad fashions. This would be a huge omnibus bill if you did all 40 recommendations at once, and we probably don't have the resources to do that. So then we decided, because we still had some time left before we needed to publish, we needed to make a project management plan that laid out the actions that made these recommendations something feasible. We didn't just want this to be ideas that went up on a shelf and never got done. So we wanted to show that what we were saying needed to be done, that these recommendations, they could be done if they were done in a logical order, if they were done in sequenced actions that made this work. And so that's what we did with the comprehensive plan. So if you have not looked at the comprehensive plan, it's not a executive summary of the national strategy. It is an action plan to make the national strategy work. And so we recommend going through that, looking through the tables. It phases things in a nominal time frame, which is the acronym LIFT, leveraging what we currently have so that we can get AAM operations going. We don't want to stand in the way of innovation. Using this time while AAM aircraft are getting on their feet, are getting into certification, while we're in the demonstration period that it's about to begin with our integration pilot program. During that time, we need to be engaged in heavy research and heavy policy development, working with Congress to solve a few things that are going to make AAM work better, and getting those answers down. And then we're going to need to start forging the regulations and the infrastructure that's going to allow all of this to work so that we can transform to a fundamentally different airspace and infrastructure that is allowing these things to operate routine and at scale, the way that will make them profitable and the way that will help Americans across the country be able to make aviation, hopefully, a part of a regular experience. Next slide, please. So, the challenges that we identified and the recommendations that we came up with. Well, the first, I need to note that you're not seeing anything about FAA certification in the national strategy. We decided early not to talk about certification of the actual aircraft, because that is solely the FAA's responsibility. And what the national strategy is meant to do is talk about things that affect the federal government at large. So no, you're not going to see our plans to streamline certification. The FAA is working on that. They have their own documents that they've published on that. And they've actually been working with other nations. There's a roadmap to autonomy that has the Five nations on it that the FAA has put out. The FAA is currently working very hard on how to streamline certification without sacrificing safety and looking at ways to do that. But that is not featured in the national strategy. What we did go to first was modernizing the airspace, because the airspace is shared. The FAA is the air navigation service provider, but we're not the only ones that do that. The Department of War also has airspace capabilities. They have special use airspaces, and they have aircraft that fly under special exemptions. And a lot of that is going to have to get modernized. One thing we really see the need for in the future is electronic conspicuity. One thing that drones have taught us, and that AAM is going to really emphasize, is we need to get to a point where we are transferring digital information in rapid succession so that all aircraft know where all other aircraft are in time and space. And we can use smart math through algorithms to have trajectories known, planned for, and accommodated so that collision risks are a thing of the past. This means looking at aircraft to aircraft data transmissions, aircraft to network data transmissions. This means that any kind of ideas of UTM frameworks or other ideas that have been in the past for UAS, what we are proposing in the national strategy is XTM, extensible traffic management. It all has to be able to coordinate with what the FAA is managing. We cannot have segmented airspace, because that's not the way it works in reality. We're going to have aircraft that are transitioning from what we would call UTM airspace, 400 feet and below. You take off at 400 feet and below, and you're going to go through that airspace into operations that are above 400 feet. You're probably never going to get up to 10,000 feet in what we are imagining for advanced air mobility. But you are going to be operating in Class B airspaces where those aircraft that are at the 10,000 foot level are coming down for their landings. And we know that one of the biggest use cases that are being sought by industry are going into those same airports. But we also have other traffic that's in between that 10,000 to 400 feet. We have military traffic. We have police helicopters. We have news helicopters. We have air tour operators in urban areas. We have out in agricultural areas, we have spraying operations. We have people that fly for fun, and we don't want to discourage that, because America's always had a strong general aviation population, and we want to keep that going. That's a beautiful thing. But what we do want is to be able to make sure that everybody else avoids everybody else. That is fundamentally the job of the FAA at the end of the day. Don't let anybody hit each other in the air. And so getting to that digital transfer of information and that secure digital transfer of information, so that information is anonymized. If we don't find a way to anonymize it, the military won't play. The general aviation community will resist. They generally don't want people to be tracking what they're doing when they're only flying for fun. And we get that. So finding a way to make it about true collision avoidance and not about tracking where people are flying is the goal here. And we think we have the technologies today. We have to find the way to use them and to make sure that they're transmitting at a rapid enough pace and at a reliable enough pace to be used for radio navigation. So those are the challenges. So here are our recommendations. We're going to establish requirements for future air traffic control automation systems and decision support tools. We are not envisioning an air traffic system that does not have any humans in it. What we are saying is that the automation needs to graduate to the level where humans are overseeing a system and looking at it from a system point of view, and that the automation does the interpreting part, does the finite math and the collision trajectory risks, all of that's being done by the air traffic controller now with their highly specialized skills. They'll still need those skills in order to make sure that the automation is operating the way it should. But at the pace and capacity and number of operations that we're asking them to manage, they're going to be managing the machines that are managing the separation itself. That's the future, the way we projected it in the strategy. We need to research, develop, and test new CNS, new surveillance, new communications Again, we need to go digital in order to allow for faster transmission and secure transmission. We need to find new surveillance solutions because radar doesn't work in urban environments. It doesn't work in low altitude cluttered environments like forests or other things where cliff areas and things. We need other solutions, and we think we have them. And then we need to research and development the requirements, roles, and responsibilities that will be expected of third parties for complementary air traffic services management. And that's an open question. There are a lot of folks that would like to see the FAA stay in charge of air traffic control across the board, but that's going to require a lot of capability building because the resources of the FAA are not infinite. They're very finite and they're already stretched. And so it's finding the right solution, whether that be finding private management solutions or whether that be finding the automation tools that allow the FAA to stay ultimately in charge and have certain data that's allowed to be provided into the systems that the FAA relies on and keep secure. But all of that needs to get figured out. It needs to get figured out while we're doing the brand new ATC. Our challenges for infrastructure are that we need more of it. But we need to do it smartly. We need more spectrum. We need to be building from the underground up. We really need to tackle the energy that's going to be needed in order to make this work. And so making sure that our grids can support what it is we want to do, making sure that where we're going to have operations, we want to be able to allow for multiple operators. So if we'll use real world examples, if Joby has one charging system, but Beta has another charging system, and Archer has yet another charging system, but they don't. There is some commonality, but there are differences. If I'm creating a fixed base operation or a vertiport where I want all three of them to be able to fly because competition will drive down fares and people will be able to use it. Well, I want to build a FADO that's big enough to accommodate all three very different types of aircraft there that I'm talking about. But I also need to have the different charging units and the requirements for their energy draw compared to the other's energy draw. So we want to encourage standardization of energy as much as we can, but we also know this is a private industry getting up, and that often these things are settled in private industry. You know, the FCC didn't declare that it must be HD DVD or Blu-ray. Blu-ray eventually won out. It's probably going to work that way in charging systems, but we need to know what that general power draw is going to be to help people plan. We need to know what, how many operators you should expect to accommodate, what the fire response is going to be if there is one, what rescue services will be needed if there is one, what maintenance services will be needed at what intervals. And so we need to develop the smart planning tools that will allow the states and cities that are really wanting to build these network of vertiports to start making the smart decisions, the smart investments. Are you going to need a substation? Are you going to need transformers? Well, those can take years to order, and we need to be able to help people plan so that they can start figuring out that underground part before they pour concrete. And then when they're ready to pour concrete, we encourage in the strategy, you really need to be working with the FAA, because if you plan a vertiport in a place where the airspace just isn't going to work, well, now you have a very nice concrete platform. And if you followed the strategy, you have it with great energy supplies coming to it, but ultimately we can't allow anything to fly in and out of there. So it's got to be coordinated, and it's got to work with the FAA from the very beginning of the planning stage. And that's something we really wanted to get out there. And then spectrum. Spectrum is a hot commodity. It's a scarcer resource than oil, than energy. And we can't make more spectrum. There's only so much of it to go around. Most of Congress's focus and most of the FCC's focus is on making sure spectrum is used for broadband. It's making sure that it's used for cellular companies, because that does bring a lot of benefits to people, but that leaves very little spectrum that's left for purely federally reserved purposes. Right now, radio navigation is purely federally preserved on the L band and K bands. And we know that, for instance, ADSB works great for today's aviation, but we're already seeing saturation in certain markets because we have very limited bandwidth for ADSB. So in New York, in Miami, in LA, we have issues where we're running out of space for other people to be jumping onto ADS-B. ADS-B was also built to keep things 5 statute miles apart, and in some cases where we have found it appropriate, 3 statute miles apart. But when we talk about AAM at scale, and if you want to get to UAS, which, by the way, we did not consider UAS as part of AAM. I should have put that out there as well. AAM is considered different. These are type certificated. These hold passengers or large amounts of cargo. We were not talking about drones when we did the AAM national strategy. But in a similar way to drones, AAM is going to need smaller separation minima in order to work at scale. AAM is going to need a separation minima that is basically aligned with safe wake distances and very little more because you want to be able to get that frequency and the operational tempo going in small spaces. And so that's going to require spectrum solutions that are more advanced than what ADS-B is. And it might be either a new form of that. It might be trying to find a digital way to use the spectrum, the very high frequency spectrum that we already have, or it might be trying to find ways to use the cellular infrastructure that's out there for CNS. There are research projects that are looking at both avenues, but we need to figure out how that's going to work in order to allow these digital transmissions and these smaller separations. Go ahead. Next slide, please. So our recommendations. I ended up talking through our recommendations while doing the challenges. I'm sorry. We're going to use existing regulations to get going. We're going to engage with states on future models of financing, and that's really got to be with Congress as well. But states and Congress really need to figure out how are we going to fund electric aviation, because right now there isn't. We fund things off of fuel and excise taxes. And so we have to identify the facility and equipment that will allow for higher automation of aircraft. We do believe that there's going to be infrastructure guides that are going to be part of this, and that's got to go in there. We need to expand our vertiport design guidance. That is happening. The FAA is already working that. Researching energy infrastructure needs, that's going to be a part of the IPP. Addressing aviation spectrum, we really need to work that with the FCC and with the NTIA, and we're going to continue to do so. Developing complementary position, navigation, and timing options. If that gets denied, right now, so much of aviation is dependent on GPS that we already had a concentration on trying to develop complementary position, navigation, and timing. We really need it for AAM. It's only going to continue to stress how important GPS is and how much a GPS loss will hurt aviation in general, especially when we're using it to go through confined places like urban canyons. And then we need to develop enhanced weather forecasting and sensing network capabilities at the micro scale. That's recommendation 2.8. It has subsections to that one. The original AAM aircraft that are coming out right now for certification are not designed to be highly weather tolerant to go into IMC conditions. They're going to need to have advanced detection systems. And frankly, if they're going to be operating in urban environments and they're going to be trying to present a good passenger experience, they are going to really want to avoid turbulence, wind shear coming off of buildings, downdrafts coming over buildings. If you've ever seen a wind model of what happens around tall buildings or what happens in urban landscapes with wind, it's crazy. And so being able to detect that and then also transmit intelligently where turbulence is found to other aircraft in a network is part of what we're talking about, a nowcast system that we'd like to develop that's in the 3-kilometer from an aircraft range versus what we currently have with AWAS. Next. Security. We need to get people on board. We need to get their luggage screened. We need to have things vetted, but we need to do it in a smart way that doesn't take TSA's resources farther than they're able to go, but also doesn't create incredibly long waits, as we currently see, for our national airspace system at every single vertiport in the country. We can't just recreate what we have. We have to look at the risk. We have to assign logical risk scores. And we have to decide how are we going to handle this smartly, whether that's through more advanced vetting of specialty crews, whether that's through screening in more strategic places and then allowing things to go through those areas. But we do need ways to do this. Smarter looks at biometrics, cybersecurity, supply chain. All of that was discussed in our recommendations. Um, Next slide. We ultimately came with, we're not going to change the security system right now. What matters is when you enter into the national airspace system, you will still need to be vetted, screened, and make everything. We're going to monitor how this grows. We don't require general aviation airports and folks that are flying in general aviation. Even like air tour operators, they don't have people screened before getting on board. So at the level that AAM is probably going to start, it's probably fine where it's at. But AAM intends to grow and be commercially happening at far greater tempos than air tour operations and other things. And so what we don't want is for that to be weaponized in the way that we saw commercial air transportation weaponized in 9/11 and other cases. So we need to figure out where that greater security risk hits and where that greater security response needs to be put in. That's what that's about. Then we need to look at new ways to do vetting and screening, and TSA is actively doing that. Then we also need to look at the cybersecurity vulnerabilities. Right now, an aircraft itself is very secure, but an aircraft is a closed system. Well, with AAM, especially we remotely piloted advanced air mobility and eventually autonomous advanced air mobility that will have ground connections that help with the navigation pieces. It's not going to be the same closed system that an aircraft is today. So the cybersecurity protections that we have in airworthiness now has to spread to operations as well. And operations generally have not had cybersecurity as considerations. That's got to happen for the FAA. That's got to happen for TSA. One of the conversations that we had was with an operator that was designing a charger that also downloaded data from the aircraft and uploaded data to the aircraft while it's charging the aircraft between missions. And we thought, neat, those of us on the aviation side. But the person who was with us from the TSA was like, wait, you're creating a huge cyber vulnerability there. You're like, who has access to this charging port now? And it struck the TSA agent, none of us, but that was something we needed to think about: is how is the cybersecurity risk expanding with the data that the data migration expansion that's happening as well. And then, of course, our supply chains. We need to make sure that we actually have the ability to get AAM working and at scale, which is going to involve maintenance, which is going to involve parts, which is going to be, if these things are going to be produced in the hundreds to eventually thousands per year, the supply chains to support that are going to have to be robust. All right. Next. Automation. Automation became its own challenge. And while I said we did not touch FAA certification, we did touch this one aspect of it. How do we validate and verify automation that is safety enhancing and also allows us to be more efficient? And this is a problem that affects more than just aviation. This is happening on the roads. This is happening at seaports. This is happening at rail stations. This is and the answer is probably going to be very similar for how we as the government say this is safe to operate on its own. It's a difficult nut to crack. Today, when you look at software, someone takes the code, prints it out, goes through it, and makes sure that there's no weaknesses. They look at the if-then logic of codes, but what if that if-then logic isn't static? It's not something you can print out because it's going to stay that way for the life of the machine. Well, that's a problem. If we are talking about softwares that adapt rapidly, that self-adapt, or that make their own decisions, and I do put that in quote because they don't have the ability. AI currently does not have the ability to make context-based decisions the way humans do. But as we were talking about this, what it is, it's highly adaptive and it's coached rather than programmed in order to get to the right solutions. Well, then how do you test that? Not in the way that we've currently done certification. You have to find new ways to do that. The FAA is working on it, but so is NASA and so is the Department of War. And so one of the things is when we get to recommendations, go ahead and flip, is we said we all need to be working on this together so we come to the same conclusions. We don't want an aircraft creator to create a great software system for flying its own aircraft that the Department of War says, yep, that works. And then they go to the FAA, perform the exact same test, and the FAA says, no, we want to do more. We really need to come to a joint solution on how this is going to work, on what makes something safe to fly itself. And that is one of our big goals. We really want to look at using virtual simulated mixed reality testing to not replace today's physical testing, but to shrink the research and development curve so that we can more rapidly innovate and so that we can learn what doesn't work faster without breaking or bending metal until we need to. And then when you think you've got it all figured out in that virtual environment and you have a very high confidence interval, that's when you take the physical tests and you validate everything that you've just been doing. And our theory is that gets to fewer redesigns, that gets to fewer broken pilot aircraft or broken prototype aircraft, so that industry ultimately saves money. They're happier with the certification process. We learn more in the certification process because we're helping with that simulation and modeling and breaking things in the virtual environment before we break them in the physical environment. And everybody gets smarter together on a faster timeline that costs less. That's the goal. And then so that automation, that was it. Thank you. Thank you for anticipating. And so community engagement is a big thing. And so it's bigger than people think. It's not just trying to make AAM popular with the public. That is a benefit that will come from good community engagement. But really what we're talking about is states need to know how to work with the localities and with their constituents to say, what are your concerns with AAM? How to get past the not in my backyard factor, when of vertiports is going to take good, strong engagement. People have to understand the cost benefit of what's going in. If you see a very similar thing that's happening right now, data centers. There's a lot of data centers going in over people's objections. We would like to see AAM go in with people's endorsements so that they're not chased out. A great example is when Amazon started working in North Texas, I think it's College Station, Amazon drone deliveries. They were chased out of town because it happened without getting the public consent first, and they didn't really understand the benefit compared to the cost. It was just one day at the city council's blessing, they started hearing all of these drones operating in and out of their neighborhood. And they got upset about it. They said there was no advanced talks. No one told us what was going to happen. No one told us the noise we should be expecting. It just started. And so that's what we don't want to see for the advanced air mobility industry. We want this to be something where people are saying, okay, I understand what this is going to sound like. I think that's fine. Or I think I can handle that if it means I'm going to have a shorter commute, or in places where they really do value the quiet that much that even the ambient noise that we think most AAM aircraft are going to make, it might not be tolerable. That should be understood before concrete gets poured and before feelings are hurt and trust in the government is lost. And so we need to do actual research on what the aircraft is going to sound like so we can have those conversations with communities before the aircraft arrive. We need to have the tools that encourage accessibility in aircraft. Most of the aircraft that we went and saw, if you were in an electric wheelchair and bound to it, you're probably not going to be able to get on board one of these. Now, there are some smart designers who have figured out how to do manual wheelchairs and have enough stowage area that they would be able to do that, but that's not universal. So if these are going to be accessible, that's something that we need to start encouraging, because the Air Carrier Access Act does not apply to small aircraft like what most AAM aircraft are designing to be for 4 passengers or less. It's meant for the national scale. So that either needs to change in the regulations, or it needs to be something that we organically try to get folks to do, or we use community engagement to say, if you want to fly here, we want it to be able to serve everyone here, and make that a market-driven decision. Those are options that we need to figure out. All of those options are on the table. That's the research and community engagement to find out what's the best way to drive future accessibility of AAM. And then finding the good public use cases. So we want to clearly communicate information and guidance on the roles, responsibilities. We're never going to hand over airspace management to the local community. That's a hard stance from the FAA, but we do want to work with communities so they understand what does make good airspace decision making, what is going to work, what isn't going to work, and how we can work with them on their permitting and zoning, which is theirs, to really make the whole equation work. Then we do want to develop guidance that allows communities to do this smartly on ways that they can engage with their own citizens and get that buy-in versus that regret or that obstinance that you will have to overcome later. We want to develop the tools that will help people do this, like noise profiles that would be available publicly before the aircraft. And then identify those mission critical use cases and how they could be used. This one thing that we're excited about again is this could be used to lower costs with essential air service. We think that's fantastic. And we really want to pursue that with advanced air mobility. And then promoting accessibility. Next slide. And then challenges. We need a workforce to make all this work. And it's got to be a highly localized workforce. You need folks that are going to work at the vertiports. You need folks that know how to keep these machines running. These aircraft, they will have lower costs to maintain, but they will still have maintenance schedules. And they're different than what current aircraft have. Most mechanics today are not taught high voltage systems, but that's going to be a feature in the future. So we need to figure out the specialty occupation codes that will allow colleges to create curriculum toward those specialty occupation codes that start getting workforce in there. What is the A&P of the future? That was a lot of our conversation. What is the pilot of the future? If these things are going to have simplified flight controls, will there be specialty pilot licenses? Will they be easier to obtain, or will they have, or just different because they'll have automation focused skills versus stick and rudder skills? That's the kind of conversations that we need to have, and we need to get down soon so that people can start building those workforces. We need to encourage this in federal STEM programs, and we need the federal workforce to upskill. We need to better understand this. I can tell you there are conversations. I had the benefit of doing 3 years of this with people, but again, we were 80 people. When we go and talk about this inside of our own agencies, there are some things we talk about with simplified flight controls and gimbal stabilization programs of aircraft where people within our own agency say, what? No, don't know why that happened. Sorry, I'm not going away. And so we realized that within our own governments, we need upskilling programs that allow people to better understand these systems, the high voltage systems, the software systems that are going into these. Next. And so we need to develop an interagency action plan to determine the future workforce impacts. The Department of Labor was going to lead that. That's something that we need to get re-engaged on. Updating the standard occupational codes. That is something that data can come around. We've got some time before the next update of the SOCs, but we really want to gather the evidence that makes strong SOCs in the future. And then promote AAM and aviation in existing federal STEM programs. Next. Our overarching recommendations. And this really came to the economic part, which is supposed to be our wheelhouse, but that's how we see it tied all together. We want to develop a consistent interagency coordination effort. We didn't want things to end with the strategy. Now, the official Advanced Air Mobility Interagency Working Group has stood down, but there are still interagency efforts. The EIPP is likely going to have interagency efforts going with that, the President's Integration Pilot Program that the FAA is currently working on the evaluations of now. So that's likely going to allow interagency to come in and work with things. We were already in talks with the Department of Energy on how they could come in and help with the planning for the electrification and other things that are going on. So that would be a benefit. We need all agencies to start working this into their budgets. This isn't going to happen magically without funding. We need Congress to be looking at how aviation funding works in the future. We need to look at our own rules within the FAA. Part 135, there's a lot of overhead when you go from 9 passenger operations to anything higher. And so we want to look at, is there a responsible way to allow a middle market of aircraft to emerge and a middle market of aircraft operations to emerge without hurting safety? But we need to sit down and have those talks. We need to do those safety management review panels, and we need to look at what technologies have come out since the 1990s until now that might allow for that middle ground between the small air operator and the Part 121. Where is that space? We need to define that and do that regulatory work. continuing leveraging public-private partnerships, which is what we're doing in the EIPP, and then enhancing programmatic research at the FAA, at NASA, at the Department of War, working together to develop these pre-competitive technologies that just make things safe. So the conclusion is we want to ensure America is ready for advanced air mobility, and we think if we follow this strategy, we're going to be ready. We have presented this at the International Civil Aviation Organization, and I will say it went well. And their AAM study group, most of the other nations that were in attendance had no qualms. In fact, a lot of them asked, "Can we get a copy of this so that we can start building to it as well?" So this has already proven in the theory stage to be a thought leader, and we hope it will prove to be as we get to the implementation stage. So thank you for letting me ramble all this time about our project, but love to take any questions.
Ryan, that was awesome. Really appreciate it. I probably am just going to ask the only question, maybe a question or two, just given time. I didn't see a whole lot in the Q&A during the time, and I wrote down lots of questions as we went on. But a couple things just to note before I go into that. First of all, I really appreciated like your practical and pragmatic perspective on this whole industry as it's been emerging. And you kind of set the tone on that right up front with a lot of the stuff that you're talking about in kind of your preamble, if you will, of the presentation. I think that really resonates with like the viewpoint that Minnesota has taken on this industry and as it's been emerging. And so it was great to hear that. And a good example of that is just like looking at this industry as, yes, it's going to be great in all the things that it's going to enable, but like foundationally, like the technology that's going to come from these aircraft, from this industry maturing, it's going to benefit all of aviation. It's going to increase access to aviation, the cost of aviation, all of those things, improving the flying experience, which are things that really excite me and really excite the state of Minnesota. And so I wanted to just share that up front as something that I really appreciated in what you shared. The question that I'll ask, again, just for time's sake, is a majority of our focus is working with the airport system in Minnesota. 132 publicly owned, publicly used airports in the state. We've identified 27 of those airports in a study that we conducted that are kind of in that that are in a near-term opportunity window to support electric aircraft operations. Based on the many recommendations and things that were identified in the strategy and the implementation plan, what are some like tactical strategies, recommendations that you'd have for airports as they kind of start to think about their plans for advanced air mobility and integrating electric aviation and whatnot, kind of within the next like 2 to 3 year time frame?
Okay. Here's my super tactical advice based on the learnings that we have. One, the National Lab of the Rockies, which was the National Renewable Energy Lab, they are building something called Project Athena. And keep looking for that, because what it's designed to do, it's a tool that we've asked them to work on that is going to help airports figure out what their energy need is going to be. Again, design from the underground up, figure out what your energy needs are going to be. And what I would say, if I were talking to airport authorities, is plan to have multiple operators. Any airport you see that only has one commercial operator in and out of it, it's completely monopolized. Fares are higher than any other airport in the area, and the people pay, and you pay, because you have no leverage when you're negotiating your gates and other things like that. But if you're going to plan to have multiple operators operating out of your airport, that means you need to plan an adequate use of land. So in our estimations and as we were talking things through, we didn't put this in the strategy because we couldn't get something to validate it and to say, yes, that's the thing. But if you look at NASA's AAM integration office, they have put out a community guide. And for a multi-operator, 4 to 8 FADOs plus a small takeoff and landing runway strip on it, you're looking at about 3 acres minimum that you're going to be looking at having in order to host all of the energy supply that you need, a maintenance hangar, some level of ARF, the rescue and firefighting, and something you're going to need a space to take a disabled aircraft. You're going to need something that can move a disabled aircraft. You're going to need something to take care of the ground service equipment, and you're going to need something to facilitate passenger flow. So, and if you have multiple companies, you're going to need at least, 3 to 4 desks to allow the companies to get their passengers through, unless all of that is done through phones. So like you find ways to economize space, but understand, if you build a FADO for a company, it's probably not going to work in the long term the way you want it to than if you sit down plan for 4 FADOs for 4 companies with a stall in order to allow for regional air mobility, of 300 feet, a 300-foot runway. Like, plan now to allow for competition later, and you will reap the benefits in the future.
I like that advice a lot, and it's something that resonates with me as I talk to a lot of the commercial service airports in Minnesota, and that they're always aiming for kind of airfare, air service parity, right, and looking to get on the routes kind of equal competition from let's say an example, Rochester to Chicago, or Duluth to Chicago, or wherever to Denver here locally, right? They're always going for that parity, which drives competition, which lowers prices, which is good for consumers. So I appreciate all that. And I think that the energy management focus is something that I've leaned heavily into as well in Minnesota, because I think it's so practical, right? There's the electrification of everything on the airport, and so there's existing and near-term use cases of you can squeeze out the fruit of those investments in the near term as you electrify other parts of the airport. And it's a good segue actually into a speaker that we're going to be having on for the next month's webinar, which is from the National Rockies Lab, talking about the AE Nodes project, the Airport as Energy Node project that they've been working on. So I feel like we're in sync there, and it's a good teaser for what's to come next. So with that being said, did you have anything else to add on that, Ryan?
Yeah, if it's Scott Carey, feel free to just noodle him. Hey, when is Athena going to be done? When can we use Project Athena? Just keep asking.
We got some good Athena cute questions ready to go for the next one. I love it. Jackson, feel free to close this up here, okay?
Yep. Thank you, everybody. I have a link to the evaluation in the comments here. So please, please, please take a moment to fill that out and let us know what you thought about today's webinar. Thank you to Joe and to Ryan, and hopefully everybody here can join us again on March 19th to hear about NASA's Airports as Energy Nodes project.
Okay, appreciate it. Ryan, thanks so much again for the time. Appreciate you, and thanks all for attending.
Thank you all. And real quick to Brent, Athena is meant to estimate power needs. It unfortunately, at least in the ones that I've seen and talked through, does not say how you're going to pay for it. And I was shocked when we first started. The Department of Energy does not have national regulatory power. Energy production and energy costs are extremely localized, which I learned through this process, but it's all done at the local level. So this is one where the federal government has to say, good luck, and we hope you win.
States can play a role in supporting that as well. I appreciate that. Yeah. Okay, awesome. Thank you, Ryan. Thanks all. Take care.